Okay, chaps, I've decided to make another little video. You're probably going to be watching it in your August holiday. It's about properties of determinant. So we had a little short video a while back, 6-7 minutes. I'm not going to repeat everything we learned there. I'm going to use some of it. And the reason why I've decided to do another video is, first, the most important thing is that I told you something that is not exactly right in that video. I told you that you probably don't need to remember these properties, but looking now at the exam question, I say actually they like to ask that question. So you definitely need to remember all these properties of the determinant, and you can find them in your books. Let me just figure out which page it is. Okay, so looking at your textbook, actually there is no nice list of all the properties. So what I'll do at the end of this video, I'll write them on the board and quickly go through them so you'll see. So that was the first reason, just to make sure you actually see that you need to remember these properties. They like to ask that, it comes out a lot. And the second thing is I'm going to add a couple more properties that come from the properties that we spoke about. So let's list the properties that I'm going to use today. So let's say I have a matrix, 1, 2, 3, 4, and I know, straight lines mean that's the determinant. So the determinant, let's say, is A. Now let's say we move on to another matrix, and all I did, if you notice, the second row is the same. What I did, I doubled the first row. I times it by 2. So I'm multiplying a row by a scalar. Okay. In this case, the scalar, okay, is equal to. So what I can tell, what the property of the determinant ensures that the determinant of the new matrix is 2a. So for each row that I multiply by a scalar, then I need to multiply. If I want to know what the determinant, I just need to multiply it by the scalar. In this case, it was 2. In other case, it could be something else. Right. The other thing, the other property that I need to do is what happens if I swap. If I swap rows, okay? So I swap these two rows. If the determinant here is A, then this property tells me that the determinant of this matrix will be minus A. So for each row swapping, okay, I need to change the sign of the determinant. I'll stop here for a second. It's a good thing that I just checked, because that is also the case for if I can change the columns. So if let's say, instead of swapping rows, I swapped columns. So 2, 4, 1, 3, the determinant of this one is also minus A. Okay? Then the last property that I'm going to use today is if I have a matrix which is a product of two matrices, okay, A times B, and let's say, the determinant of this combined matrix, A times B, is the determinant of the first matrix times the determinant of the second matrix. In other words, we'll put it in words, the determinant of the product of the matrices is the product of the determinant of each matrix. Okay, what am I going to use this for? So I want to find out, now just because I've seen they're asking you, these are the properties you need to remember, plus the other ones that I'll remind you later. But using these properties, you can figure out a few other things that I saw in the exam. So one here, I hope you guys can see that. I've got a matrix with a row of 0. Okay, we've come across, rows of 0, right? What will be the determinant? And the answer is, it's actually going to be 0. Okay, but why is that? Because I can write that, okay, I could have gone from, let's say, I'll write it down here, 1, 2, 3, 4, some kind of matrix. And then what I did, I multiplied this row, I multiplied by 0, right? If I multiplied this row by 0, then I'm going to get 1, 2, 0, 0, which is that matrix here. Now, I don't know what the matrix of this one, but to be honest, I don't need to. Because this rule here tells me that the determinant of this will be the determinant of that, which I don't even care what it is, because then I need to multiply by the scalar that I multiplied the row by. What did I multiply the row by? By 0. So 0 times anything will be 0. Okay, so that's a good one to remember. Okay, you need to be able to, prove it by using this rule. Okay, if I multiply a row by 0, then the new determinant will be 0. The second thing is what happens if I have two identical rows. And as we will see now, that is also going to be 0. And why is that? Okay, so let's say I have, let's call the determinant, let's say the determinant here is, I don't know, W. Okay, now what I want to do is going to take this matrix, I don't know if you can see it. Yeah, I think you can see it. 1, 2, 1, 2. Okay, two identical rows. What I'm going to do now, I'm going to swap it around. I'm going to swap the rows around. So I'm going to take that 1, 2, and I'll write that down. And I'll take that 1, 2, and write that down. Okay? I mean, what was that about? Okay? Obviously, I've got the same. It's not 12. It's 1 and 2. Okay? So I've got a new matrix. I swap the arrows. I swap the rows. But, okay, what does this rule tell me? This rule tells me if I swap rows, then the determinant is going to be negative that. So if the determinant was here W, the determinant here is minus W. But that is obviously very ridiculous because I've written the same thing on the left side, but I have minus W and W on the other side. So what does that tell you? Well, it tells you one thing, that W equal to minus W. Has to be, otherwise we've got something wrong. Okay, we've got some kind, we're not obeying the rule. But if W equal minus W, that means 2W equal to 0. In other words, W is equal to 0. Okay? So identical rows, if you have repeated rows, that means the determinant is 0. Right, last one. Last one. I'm going to write it here. Let's say I have determinant of A. I've got some kind of matrix. And I've got the inverse. Okay? Never mind what they are. What I want to know is, what is the determinant of A times the determinant of A minus 1, the inverse. Okay? Well, what is it? I'll call it, let's call it, I don't know, let's call it B. Some kind of a scalar. It's a number, right? It's not a matrix, it's a number. Now, let's use this rule. Okay? I know the determinant of A times the determinant, well, that's like my new matrix B. So let's not call that B. Let's call that one alpha. Okay? So that's my A, that my other matrix B. Okay? So I know the determinant of A times determinant of A minus 1. Okay? And I'll put actually brackets here just to show you that I'm calculating the determinant of the inverse of the matrix. Okay? That's going to be equal to the determinant of the product of these two matrices, A times A minus 1. Okay? That's what this rule will say if I'm choosing a specific second matrix, which is the inverse of the other one. But now, what do I have here? What is A times the inverse of A? Well, that's the identity matrix. So the determinant of A times the determinant, okay, the determinant of A minus 1 is the determinant of the identity. But what is the determinant of the identity? Let's look at the 2 by 2. Okay? Well, it's 1 times 1 minus 0. Okay? 1 times 1. So the determinant is 1. Let's look at 3 by 3. Well, it's actually very easy to calculate the determinant of identity matrix because they're all 0 except for 1. So I've got this one times determinant of 1, 0, 0, 1, which we know what that determinant of, that's a 2 by 2 the identity matrix is 1. So the answer again is 1. So it's always going to be 1. So in other words, the determinant of the identity matrix is 1. And that means the determinant of A times the determinant of A minus 1 is 1. Or you can see it like that. The determinant of A minus 1, the determinant of the inverse of a matrix is 1 over the determinant of that matrix. Okay? Cool. I'll pause here. I need to do one more thing and then we'll do the little recap. Okay, so before I go over all the list of the properties now, let's introduce something else which is called trace. It's kind of quite random. It's going to look quite random. It is being used later on in university, but I can see it was in the book. You just need to know what it is. It's very easy. So let's say I've got a matrix. It could be 5, 10 times 10 dimension, 10 by 10, whatever. Okay, I've written all the, what do you call the terms? So the A11 is the first row, first column. A12, first row, second column. A21, all the way to N. N could be any. Now the trace is basically adding the numbers on the diagonal, the main diagonal. Okay, so in other words, it's A11 plus A22 plus A33 plus until we reach the last one, ANN. Okay, it's just the sum of all these numbers. That's what the trace is. Okay, we're not really using it in anything useful here, but it is being used later. Now here I've got all the list of all the properties that you need to remember for determinant. So let's quickly go over it. Okay, that was actually wrong. If I want to know the determinant of the transpose of A, that flipped one, okay, it's simply the determinant of A. So doing the transpose doesn't really change the determinant. As we mentioned before, multiplying a row by k, by some kind of scalar k, the new determinant is k times the determinant of A. If I have a row or column full of zeros, then what I really did, I multiplied the row by 0, so therefore the determinant will be 0. We learn that now. Interchanging rows, okay, if I go from a matrix to one where I swap the rows or the columns, the determinant swap signs, okay? And that really tells me, okay, here we go. That tells me what we've learned today, that if I have identical rows or identical columns, the determinant must also be 0. The determinant of the product of matrices is equal to the product of the determinants of the matrices, and the product of the determinant of a matrix and determinant of its inverse is 1. All right, have fun.